start the discussion for infinite solutions, we need to define two things. First is a pivot, which we defined previously. But just as a reminder, it's the first non-zero entry in a row when the matrix is in row echelon form. The next thing we need is a pivot column, which is a column that contains a pivot. So if I know there's a pivot in the first column, then the first column would be a pivot column. Now that we've defined that, let's jump straight into an example and see what happens. So here's my linear system. Let's work on solving it and see what happens. So the first step is to move to an augmented matrix. Here's my augmented matrix. The first step is to get a 1 in the first row, first column, which we already have. So now let's get zeros below it. The second row has a -2 in it, so we need to add 2. So we'll do -2 row 1 plus row 2. We know the first row here isn't going to change. I then have 2 times 1 is 2, minus 2 is 0. 2 times -4 is -8, plus 3 is -5. 2 times -9 is -18, plus 8 is -10. And 2 times 1 is 2, plus 3 is 5. For the third row, I currently have a 1 and I need a -1. So I'm going to do negative row 1 plus row 2, plus row 3. So -1 plus 1 is 0. 4 minus 1 is 3. 9 minus 3 is 6. And then -1 minus 2 is -3. The next step, we want a 1 in the second row, second column. So we'll do -1/5 row 2. We know the first and third rows won't change, and now we just need to divide by -5. That gives us 0, 1, 2, and -1. Next, we need to get zeros both above and below this 1. The first row has a -4, so I need to add 4. So we'll do 4 row 2 plus row 1. I know my second row won't change. I then have 4 times 0 is 0, plus 1 is 1. 4 times 1 is 4, minus 4 is 0. 4 times 2 is 8, minus 9 is -1. And 4 times -1 is -4, plus 1 is -3. Below the 1, I have a 3, so I'm going to need to subtract 3. So we'll do -3 row 2 plus row 3. -3 times 0 is 0, plus 0 is 0. -3 times 1 is -3, plus 3 is 0. -3 times 2 is -6, plus 6 is 0. And then -3 times -1 is 3, minus 3 is 0. Once again, I need to get a 1 here, but I can't, just like I couldn't for no solution. The difference this time is the last row doesn't give me something invalid. It just says 0 is equal to 0. So let's go ahead and move these 2 rows that I have into equations. So the idea of what I've done here is this absolutely does have an infinite number of solutions. I wasn't able to actually get a single solution. But my solutions will satisfy these 2 equations, which is a much simpler condition to check than all 3 of these bigger equations. Let's see if we can try to simplify it a little more. With infinite solutions, there's a couple of different kind of variables that we have. The first is basic variables. The basic variables correspond to our pivot columns. We then have this idea of free variables. These are the other variables. Basic variables correspond to pivot columns and free variables don't. They're the ones that fall into columns that are not pivot columns. So when we write these kind of solutions, we want to solve for basic variables. So let's go back to our last example and look at the solutions. So here's our example. Our pivot columns are where the pivots are. the first and the second. So x1 and x2 are going to be our basic variables. So we want to solve these equations for x1 and x2. That gives us that x1 is equal to x3 minus 3, and x2 is equal to 2x3 minus 1. So now I have clear definitions for both what x1 and x2 need to be. x3 does not correspond to a pivot column. There's no pivot in the third column, which makes it a free variable. So x3 can be any value we want it to be. So the idea is we get to pick the free variable to be what we want, and then we have very clear definitions for what x1 and x2 do. Any value you pick for x3, we can find a solution to this system, which is the idea of the infinite number of solutions. Let's look at one more example of these. So this time I have two equations and three variables. So let's start by moving to an augmented matrix. We know we need a 1 in the first spot, which is already given to us. So the next thing we need is a 0 below it. And I'll get that with negative 2 row 1 plus row 2. The first row won't change. We then have negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 9 is 18, minus 18 is 0. Negative 2 times negative 2 is 4, minus 2 is 2. And then negative 2 times 6 is negative 12, plus 4 is negative 8. My next pivot is going to be in the third column. So I need to get that to be a 1. And I'll do that with negative 1/2 row 2. The first row won't change. And then the second row I just need to divide by negative 2. That gives me 0, 0, 1, 4. Finally, I need to get zeros in the rest of that column. And I'll do that with 2 times row 2 plus row 1. My second row won't change. I then have 2 times 0 is 0, plus 1 is 1. 2 times 0 is 0, minus 9 is negative 9. 2 times 1 is 2, minus 2 is 0. And 2 times 4 is 8, plus 6 is 14. And now my matrix is in reduced row echelon form, so let's write the equations. The first row corresponds to negative x1 minus 9x2 equal to 14, and the second row corresponds to x3 equal to 4. We can see our pivots are in the first and third columns here, so that's what we need to solve for, and x2 is going to be my free variable. So our solution is written as x1 is equal to 9x2 plus 14, x2 is any value, and x3 is equal to 4.